It is a safe. It is a safe space. All right, here we go. UH right triangles and sectors. I think we can do this without a calculator, but if we need one, no big deal. We'll get one out. It says in a right triangle ABC with right angle C. So okay, so here we go. Draw a right triangle. It doesn't have to be perfect, guys. So here's the right angle C. So then call this A and B. So AB is 9, so I'll put a 9. BC is 4, so I'll put a 4. Find the length of the missing side. So I need this side right here. I'm going to put an X in there. All I'm going to do is Pythagorean theorem. Sometimes they want the hypotenuse, sometimes they want one of the sides. So I'm just going to go x squared plus 4 squared equals 9 squared. Are we still okay, guys?
Yeah.
All right, so I'm going to go x squared plus 16 equals 81. I'm going to subtract 16 from both sides. So x squared equals, let's see, 81, 71, and another 6, so 65. So 65. And then how do I get x by itself instead of x squared? Square root, square root. X equals the square root of 65. And there it is. This is one of y'all's, this is the highest grade so far, 95. All right, here we go to the next one. In a right triangle ABC with right angle C, so again, we're doing the same thing. Right angle C, not to scale. Put A and put B. AC is 14, so this is 14. BC is 5, so this is 5. Find the length of the missing side. So I want my hypotenuse. All right, here we go. So I'm going to go 14 squared plus 5 squared equals x squared. Are we still okay? I believe 14 squared is 196. And then 5 squared is 25. So 196 plus 25, that's 221. And then how do I get x by itself? Square root, square root. X equals the square root of 221. And there it is, guys. How are we feeling so far, guys? Okay. I'm going to go to the next question. This time they gave us a shape. They gave us the triangle. And we're happy for that. AB is 13, so I'm going to put 13 right here. This is a 45, 45, 90 degree triangle. How do we know that? Yep, and then we have 90 degrees there, so that means these two must be 45. So in a 45, 45, 90 triangle, we have n, and square root of 2. Are we still okay? All right, so here we go. That 13 is the hypotenuse. I'm going to put the 13 right below that. Are we still okay, guys? So I'm going to write n square root of 2 equals 13. Next, I'm going to get n by itself. So to get n by itself, I'm going to divide by square root of 2. Does that make sense? So now I have n equals 13 over square root of 2. Oh, where's the answer? How come they don't write it like that? Because they rationalize it. So when you take what you do, you go and multiply that by square root of 2 over square root of 2. So then we get 13 square root of 2 over 2. And there it is. Are we okay? Okay. All right. Let's go to question number 4. Okay, ready? All right. So they tell us this is another 45, 45, 90 degree triangle. Put 45 in there. They tell us that AC is 8 square root of 3. So I'm going to put 8 square root of 3. So this is also 8 square root of 3. And again, what am I doing? I'm just writing the formula. n square root of 2. You could also do Pythagorean theorem if you want to. So I take this leg of 8 square root of 3, and I'm just going to multiply it by square root of 2. 8 square root of 3 times square root of 2. So square root of 3 times square root of 2, that's square root of 6. So it's going to be 8 square root of 6. And there it is. And I look for that answer, and it's on the next page. Are we okay so far, guys? All right, let's go to the next one. In the figure below, an altitude is drawn to the base of an equilateral triangle ABC. If AC is 4, find A and B. Okay, well, AC is 4. Let's see. This distance here is 4. And this is an equilateral, so that means all sides are 4. and this entire side is 4. Well, if the entire side is 4, that means A plus B is 4, and this cuts it right down the middle. So what do you think A and B is? Yeah, 2. A equals B, which equals 2. Do you see how we did it, guys? Okay. Am I going too fast? Okay, so am I going okay? Martinez, am I going okay? Okay. All right. Sorry, guys. Next time I'll make sure to bring pizza or something, you know? Yeah, it's recording. All right. In the figure below, an altitude is drawn to the base of an equilateral triangle ABC. So if AC is 6, so this is 6, find C, the length of the altitude. So they want the length of the altitude. Do you guys see this triangle that I'm writing? That's a 30, 60, 90 triangle because it's an equilateral triangle. But I'm cutting that in half, so it turns to a 30, 60, 90. That one in red, right? So if this is 6, that means the short leg here has to be 3. See? In a 30, 60, 90 triangle, n square root of 3, and 2n. So the 2n was 6, so half of 6 is 3, so that's 3. So you didn't need that, but it helps. And then the long leg, which is where the 60 degree aims, is 3 square root of 3. So there it is. So I look for 3 square root of 3, and that's my answer. Did that make sense, guys? Escamilla, did that make sense or no?
Actually, could you go over where you got 3 from again?
Yes. You see the triangle in red? That it's an equilateral triangle, so this side is 6, this side is 6, but I don't need the whole side. I just want half of that. I want this little half. Well, if the whole thing is 6, that means this short leg is 3. You could also done it from this, from the 30, 60, 90. See, the 30 degrees is that distance here, the blue one. So that is half of whatever 6 is, my hypotenuse, for this blue triangle that you're seeing. Does that make sense?
Yeah. Hypothetically, could you also use that right here for this answer right now?
You don't know the side C. So you have 2 sides, 2 unknown sides. So it's best to use this. Now, if you knew that this is 3 and this is 6, then yeah, you can use Pythagorean theorem to find that length.
Yeah, that's what I thought.
Oh, yeah. You can say 3 squared plus C squared equals 6 squared. 3 squared is 9. And 6 squared is 36. C squared equals 36 minus 9. What's that? 20, 36, 26, 27. 27. And then square root. This is 9 times 3. The square root of 9 is 3. 3 square root of 3. You get the same answer. Cool? Cool. I'm still thinking about the chicken nuggets. They're serving chicken nuggets, guys. Oh, okay. Sorry. All right, here we go. AC is 10. So I'm going to write 10 right here. Find X and Y. This is the 30, 60, 90 triangle, guys. 30, 60, 90. The 10 is opposite the 60 degrees, so that means I'm going to put the 10 right here on bottom of this one. And n squared of 3, 2n. That's the properties for a 30, 60, 90 triangle, always. So I'm going to write n square root of 3 equals 10. The short leg is this guy. This is your n. And the long leg is this one. So this is the 2n. So I'm going to see what this is. I'm going to get n by itself. Divide by square root of 3. Divide by square root of 3. N equals 10 divided by square root of 3. Now I need to rationalize it. Times it by square root of 3 over square root of 3. So you have 10 square root of 3 over 3. That is your n. That's your y. Does that make sense? All right, to get your x, you got to multiply by 2. So 10 times 2, 20 square root of 3 over 3. And there it is, guys. I just find those answers. So x, 20 square root of 3 over 3. Y, 10 square root of 3 over 3. You doing all right, Escamilla?
Yeah.
You doing all right, Ortiz? Okay. Are you loving this?
Yeah.
Okay. I know it's not McDonald's, right? Are you loving it? But yeah. All right, here we go. Again, 30, 60, 90 triangle. And I know, guys, this is kind of lengthy, so if you're tired, I know this can be cumbersome. But hopefully, thankfully, we still have another day here. So I'm going to write n n square root of 3, 2n. Let's see, they gave me AB, that's hypotenuse. 8 square root of 2. So I'm going to write 8 square root of 2 below the 2n. So 2n equals 8 square root of 2. Then to get n by itself, I just divide by 2. N equals 8 divided by 2 is 4. 4 square root of 2. So that's what this is. 4 square root of 2. Do you see what we did? So where's the 4 square root of 2? This is that x. Excuse me. There it is. And then the y, that's the long leg. So I'm just going to multiply by square root of 3. So here it is, n square root of 3. I take the 4 square root of 2, that's what n is, and I multiply by square root of 3. See, that's what the square root of 3 is. So 4 square root, 3 times 2 is 6, 4 square root of 6. That's what y is, 4 square root of 6. So there it is. So we look for that. Oh, they got this one wrong. I mean, they had it. 4 square root of 6 is y. So this one right here. And 4 square root of 2 is x. How are we feeling, guys?
I'm actually very lost.
Okay.
How did you? Okay, so I kind of lost track after 4 square root of 2. Like after you divided that.
Okay, how I got 4 square root of 2?
Well, I know how you got there, but then how did you proceed forward with that?
Oh, I just multiplied by square root of 3 because I wanted the long leg. So I take the 4 square root of 2 and just multiply by square root of 3.
Okay.
And whatever, like law of exponents. So square root of 2, that's like 2 to the half times 3 to the half. Well, law of exponents, that's a half. You can just go 2 times 3, 6 to the power half. And half means square root, so square root of 6. I don't know, maybe I confused you more with that. I'm just doing law of exponents, miss. Square root of 2 times square root of 3. That's inside the house, or that's inside the radicand. So it's just say the square root. Square root of 6. Yeah. Side note, square root of n times square root of n equals square root of mn. That's all it is. Yeah, law of exponents, miss. Algebra. Okay. Next one. Here we go. Not to scale. DF is 37. EF is 35. And they want tan D, so I'm looking at this angle, and cosine F. I'm looking at that angle. So cosine F you can get right off the bat. So cosine F is just adjacent of our hypotenuse. So let me write SOHCAHTOA. SOHCAHTOA. So adjacent, 35, over hypotenuse, 37. Cool or not cool? Now, for the tan, I need to figure out what this distance is. I'm going to call that x. And I'm going to go x squared plus 35 squared equals 37 squared. So it looks like I'm going to need my calculator here. It might be a special right triangle, but I'm just going to take my calculator. Oh, look, you like that sloth? It's a cute sloth. You should give my video a thumbs up if you think the sloth is cute.
You want us to put notifications on too?
If you want to. All right, so here we go. I'm going to type in 35 squared. And 35 squared is that number. And 37 squared. Oh, we got big numbers. And I'm going to take this number, 1369, and subtract 1225. So x squared, I'm just minusing 35 squared. So 37 squared minus 35 squared. So x squared equals, what's that, 144? So this number minus this number, 144. Square root to get x by itself, x equals 12. So there it is. I got 12. You can just do square root of that, right? Square root of 144. All right, here we go, guys. Now that I know that that's 12, tan of D, opposite, 35, over adjacent, 12. So there it is. So look for that, 35 over 12 and 35 over 37. Are we okay? All right. Say it again. No, you're good. You're good. You're welcome, miss. Okay. Next one. Suppose that theta is an acute angle of a right triangle that tan theta is 4 squared of 2 over 3. Remember, SOHCAHTOA. SOHCAHTOA. Find sine theta and cosine theta. Okay, so here we go. Here's my right triangle. I'm just doing a quick grid. You don't need to do a grid. There's my theta. And tangent is opposite over adjacent. So I'm going to say 4 squared root of 2 and 3. So I'm going to do Pythagorean theorem because I need the hypotenuse. So I need r. So here we go. I'm going to go 3 squared plus 4 square root of 2 squared equals r squared. Are we still okay? 3 squared is 9. 4 squared is 16. And square root of 2 times square root of 2 is 2. You can use a calculator if you don't like that. 16 times 2 is 32. 32 plus 9 is 41. So when I take the square root, r equals the square root of 41. Are we still okay, guys? All right, so here it is. I'm going to put square root of 41 right there. Now I'm ready. I'm going to go sine. They want sine, so I'm going to write sine theta opposite 4 square root of 2 over hypotenuse, square root of 41. I'm going to multiply by the square root of 41 over the square root of 41. And here's what you get. Sine theta equals 4 square root. 41 times 2 is 82 over 41. We still okay? All right, cosine theta. Cosine theta is adjacent over hypotenuse. 3, oh, what happened there? 3 over square root of 41. Are we still okay? Times square root of 41 over square root of 41. So you get 3 square root of 41 over 41. So there it is. That's cosine, and there's sine. So here it is. I got it right. Okay. How are we feeling, guys? Can we take some more? Okay. Let me know. Ask me questions. Are we okay? Okay. I know. When it's late, it's just like, you've already gone through school and you're like, man, I'm doing more math. All right, here we go. Again, an acute angle. So I like to draw reference triangles to what we've been doing all this time. So theta, secant or reciprocal of cosine. And remember that cosine is adjacent over hypotenuse, 3 over 8. So adjacent, 3, hypotenuse, 8. So I'm trying to find this distance. I'm going to call that a y. And I'm going to go 3 squared plus y squared equals 8 squared. 3 squared is 9. Y squared equals 64. 8 squared is 64. Minus 9. Minus 9. Let's see, what's that? 54, 55. Y squared equals 55. Square root. Y equals the square root of 55. So I come over here and I'm going to write square root of 55. All right, here we go. I'm going to say, what do they want? Cosecant? Cosecant is the reciprocal of sine. So sine would have been opposite of hypotenuse. So I'm going to go hypotenuse, so 8 over the square root of 55. Then rationalize it, times square root of 55 over the square root of 55. And you're going to get, let's see what we're going to get. You're going to get 8 square root of 55 over 55. So there it is. That's cosecant theta. We're almost done, guys. We're almost done. Tan theta equals opposite over adjacent. Square root of 55 over 3. Let's look for that. 8 square root of 55 over 55 and tan square root of 55 over 3. I know they wrote it funny. They put 1/3, but this is square root of 55 over 3. We're still okay, guys? Okay, let's go to number 12. Convert the following degree measure to radians. Okay, 45 degrees. We're going to multiply this by pi over 180 degrees. 45 goes into 180 4 times. So there it is, pi over 4. Do you see how we did it, guys? I can do it again. Do you want me to do it again? Okay, I'll do it with a calculator. 45 degrees times pi over 180. So just go 45 pi over 180. I would just do this. Put this in the calculator, and it's going to turn into a fraction. So let's look. 45 over 180. And then just turn into a fraction. Math, frac, enter. And then just remember you have a pi in the numerator. So pi over 4, or 1/4 pi. 1/4 pi or pi over 4. It means the same thing. Cool. All right. Convert the following radians measures to degrees. Well, I have 8 pi over 9. 8 pi over 9 times, whenever you're getting this to degrees, we're going to multiply by 180 over pi. The pi's cancel out, and you just go 8/9 times 180. So I'm going to go 8/9 times 180. So there it is, 160 degrees. How are we feeling, guys? Okay. All right. Let's go to the next one. Oh, perfect timing, miss.
I'm here, sorry I'm late.
No, you're good. You're good. You're good. Perfect timing. You just reached the tougher questions. If you want to grab a packet there, you're here for the UH, right? Not Decathlon.
Oh, you don't need to have one.
Oh, Decathlon. She's in Miss. You're in, go to Miss Garcia's. But grab one of those, and you can follow along with my video later on. You know what I mean? And then if you think the sloth is cute, you give my video a thumbs up.
Okay, wait, do I need this or? Like,
Well, if you want to follow along with the video, you don't need
it'll
it.
just
You know?
help you with the quiz?
Yeah, yeah, it will.
Oh, you send this first, yes?
Yeah, in the library.
Okay.
Okay. Make sure you sign in.
Okay.
Okay, here we go. To find the length of the arc of a circle, think of the arc length as simply a fraction of the circumference of the circle. If the central angle theta defining the arc is given in degrees, then the arc length can be found using the formula. Look at all that. Look at all we just learned. So it's like a percentage. This theta over 360 acts like a percent of circumference. Use the formula above to find the arc length theta S, where theta equals 30 degrees and r equals 9. So S stands for arc length. In case you don't know what arc length is, let me give you a visual. See that 30 degrees? So I have a circle, and it's only covering 30 degrees. So here's 30 degrees. So this is what we're looking for. We're looking for this distance right here. See? And the radius is 9 centimeters. So circumference of a circle is 2 pi r. That's where that 2 pi r came from. So you're going to go S equals 30 degrees over 360 degrees times 2 pi times 9. See? You take your calculator. What's up, Delgado?
Can I use a calculator?
Yeah, of course. You're going to bring it back?
Yeah.
Okay.
I'm actually doing this right now.
Okay.
It doesn't have any.
Okay. What are you guys working on?
I'm working on English.
Okay. Well, that's what we're working on too.
Oh, really?
Yeah, that's what we're doing right here. Look.
Oh,
See?
okay.
Yeah.
For Abigail, can you come on?
Oh, you're working on decathlon?
I
No.
thought you were working on it.
No, I told you that today we're going to be doing the UH quiz. That 3 is a crowd, remember?
Oh my gosh.
I'm
doing
recording.
that right now.
Yeah, come on in. All right, here we go. I'm just going to put this in my calculator. So I'm going to go 30 over 360. 30 over 360. And don't put the pi in there, guys. Just go times, just multiply the 2 and the 9. What's 9 times 2? Just multiply by 18. And there it is. What are you going to put in the top? The pi.
Wait, I love that.
3 pi over 2. Do you see how we did it? Okay. All right, here we go with the next one. If the central angle theta defining the arc is given in radians rather than degrees, then the arc length can be found using the formula 0 theta over 2 pi times 2 pi r, which simplifies to r theta. Yep, that's if you have it in radians. The 2 pi's cancel out, see? So my surface area is going to be, my arc length is going to be theta times r. And that's it. Cool or not cool? All right, so here we go, guys. So we have this angle. Remember what that means. So what you're really looking for or what you're really finding. So here's my circle. And here's this angle, 5 pi over 3. So let's see, 3 double. So you're doing this. This right here, that angle, that is 5 pi over 3. So what you're really finding is this in red. You're finding this in red. Do you see that? So here we go, guys. S equals 5 pi over 3, and then you just multiply by the radius times 11. Well, I guess you can say r theta, so that's fine. So 5 times 11, let's see, what's that, 55? 55 pi over 3. So that's my arc length, 55 pi over 3. Do you guys like the visuals? When I put the visuals, okay. How do we feel? Any questions? Okay. If you guys don't need it, but if you want to follow along with this, I guess if you're on the quiz, you can follow along there too. But if you wanted to, you can always look at that video later on. All right, we're now in question number 16. So here we go. Question number 16. It says, find the perimeter of a sector of a circle with central angle 7 pi over 4 and the radius 10 feet. So let's do a visual. So here's a circle. And the radius is 10. So here we go. This is 10. And 7 pi over 4. You're pi over 4 away from a full revolution. So you're probably something like right there. And this is 7 pi over 4. So what you're finding is this. You're finding this in purple. You're finding Pac-Man, essentially. You're finding this. This is what perimeter means. And you're finding, there it is. You're finding that. Everything in purple. Cool or not cool? So here we go. I'm going to find the arc length first. And then whatever the arc length is, I'm going to add 20 to it. So S equals 7 pi over 4 times 10. Child, why are you doing that? Well, because that's my formula. That's how you find arc length when they give you in radians. So r theta, or theta r. So here we go. So 10 times 7, that's 70 pi over 4. Are you looking for decathlon?
Oh, I'm working on the delta math last time.
Oh, okay. That's fine. Yeah, come on. Yeah, go ahead. Get one of these. Get one of the big ones. These. Yeah. And this reduces to 2 goes into 70 35 times, and then 2 goes into 4 twice. So 35 pi over 2. Are we still okay? All right, so here we go. Perimeter is equal to 2r plus s. S means arc length. And child, why are you doing 2r? Because I have a 10 here and I have a 10 there. So perimeter is equal to 20, 10 times 2, plus 35 pi over 2. See? You guys can come in. You guys can come in, guys. There's plenty of table. There's plenty of room. Okay, or not. So there it is. Yeah. Where'd I get the what?
The second 10 from.
Oh, well, that's my radius. And they wanted my perimeter. So remember that perimeter means literally like the perimeter, the outside. So, yeah, pretend like this is a fence. I want to know how long that fence is. So, 10 plus 10 plus whatever that is. Core or not core? Come here.
So like you always multiply the radius by 2.
Grab one from there, miss. In this case, yes. In this case. You can come in. You can come in, Morales. You guys can come in, guys. If you're here for the UH, there's some packets here. If you want to follow along, you don't have to. Watch the video, give it a thumbs up, and keep us locked. Let's see what I don't know. We're not done yet. We're almost. We're in 17. You came just in time. All right, here we go. Look what it says. To find the area of a sector of a circle, think of the sector as simply a fraction of the circle. All right, guys, focus, 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 focus. If the central angle theta defined in the sector is given in degrees, then the area of the sector can be found using the formula. So think about it. This is like a percentage, like a percentage of area sector. It's like a percentage of the area sector. Area of a circle is pi r squared, guys. So here we go. I'm going to go, look, it says use the formula to find the area of the sector where theta is 270 and r equals 5. Okay, so what I'm finding, So here it is. Here's what I'm finding. You can already see what's happening here. This is 270 degrees. So you're finding the area of this sector. What percentage is that of the circle? 75%. So you could look, check it out. We're going to do it both ways. I mean, I guess you can just check 270 over 360 is 0.75. Look, 0.75, because that's a percentage, times pi times 5 squared. Come on in, Dina. You're welcome. Come on in. So 0.75 times pi times 25. I take my calculator, and I'm just going to go 25 times 0.75. Leave the pi alone. So I'm going to go 25 times 0.75. And there it is. Turn that into a fraction. Math, frac, enter. 75 pi over 4. 75 pi over 4. You could have also typed in 270 over 360. Look, 270 over 360 is 3/4. See, guys? It is 3/4. 0.75. Turn it into a fraction. It's 3/4. Are we still okay, guys? Okay, we're almost done. We're so close. A sector of a circle has central angle 2 pi over 3 and an area 16 pi over 3 square feet. Find the radius of the circle. Okay, so here's a visual. Do you guys like the visuals or no?
Yes.
Okay, so here's a visual. Hey, relax, relax. You guys had it angry there. So here it is. This is the 2 pi over 3. There's your 2 pi over 3. And this is the sector. And you're finding, what are you finding? You're finding the radius. You're finding r. Okay, so here we go. I'm going to go, this is my area. So I'm going to go 16 pi over 3 equals 2 pi over 3 over 2 pi. This is like your percentage. This is like your percentage. Times, don't worry, let me just stop here and then I'll see what you want. Or let's see what question you have, sorry. Pi r squared. Okay, what's up?
How did you get 2 pi over 3?
They gave it to me.
Okay.
Keep asking, keep asking.
And then why did you get over 2 pi?
Okay, because remember on the last one, remember on this one, they told me that this is like a percentage times pi r squared. But this is for degrees. What if I'm in radians? How much is 1 revolution? 2 pi. So I put it over 2 pi because context clues, that's like a percentage.
Okay.
Does that make sense?
How come it's equal to 16 pi over 3?
Because they gave me that area of that sector. It's right there.
Oh, okay.
That's the area of that sector. This in blue, that area is that. This is the percentage of my whole circle. So that's what the area is of that in blue. And that's what I'm going to use to solve for all.
Okay.
Does that make sense? You can tell me no if it doesn't.
No, it makes sense.
For sure. You're not just telling me that just to tell me that.
I still don't why did they give us both?
Okay. So if I told you, okay, side note, this is just a side note. If I told you I have a circle and that circle has a radius of 3, and I told you I want the area of this circle, you would say, oh, okay, area of a circle is just pi r squared, and you would just go pi times 3 squared, and you would just tell me 9 pi, right? Now, what if I took up 90 degrees? So you guys can see, look, that's 90 degrees. Do you agree?
Yes.
And my radius is still 3. So you know that's 1/4 of a circle. I could have done this, or you know what? Let's do it in radians, pi over 2. Look at this. I could go area of that sector, pi over 2 divided by 2 pi. This is like a percentage. That better give me 1/4 times pi times 3 squared. That will give me this area here. So if I take my calculator and I'm going to do it literally like that. If I were to go pi over 2, and I divide this by 2 pi, look, it's 1/4. 125. And then there it is. And then multiply by 9 pi, and that's 1/4. You know what I mean? Like that will be 25% of my area. So 1/4 times 9 pi. So 9 pi over 4 would have been my area of that sector for 90 degrees. So that's exactly what I'm doing here. I'm just finding the area of that in blue. So this is a percentage times the area of the circle.
Okay, yeah.
And that will give me that area. And they gave me that area. Are we okay?
Yes.
Or are you just telling me that?
No,
Are you sure? Okay. If you still have that question, come, like, don't leave. Ask me again, and we'll talk. So we're good. Okay. Guys, do we have any questions? All right, so here we go. I'm just going to find this percentage. This pi, well, okay. This is just algebra, just arithmetic. Can I cancel this pi here with this pi there? Yeah. So I have 2/3 divided by 2. That 2, I can, well, keep, change, flip. So this 2, you can put it right next to that 3. So this is 2 over 3 times 2. Say it again. Yeah, you could, but I didn't want to confuse anyone. Cancel out the 2's. I guess you could have canceled out the 2 pi's and 2 pi's if you would have seen it. Yeah. I just didn't want to do something if you guys didn't see it. Are we okay? Yeah, come on in, guys. All right, so here we go. So now I have this. I have 16 pi over 3 times 1/3 times pi r squared. Can I cancel this pi with this pi? Yeah, you can. Yes, you can cancel. What about this 3 in the bottom? Can I cancel that 3 in the bottom with this 3 in the bottom? Yes. Bam, bam. So now look what you have. 16 equals r squared. Now what? Square root it. Square root. What's r? 4. There it is. That's how we got it. This person got it right. Do you see how we did it, guys? Okay. All right. Here we go. Don't worry. I'm going to go slow. We're going to go slow. This is really more geometry than anything. A car has wheels with a 9-inch radius. If each wheel's rate of turn is 6 revolutions per second, find the angular speed in units of radians per second. Underline radians per second. All right, here's how you're going to do it. Use dimensional analysis. What do they call in chemistry? Stoichiometry. So I'm going to go like this. 6 revolutions per second. It's a T. In 1 revolution, how many radians do I have? In 1 revolution, how many radians do I have? 2 pi radians. Do you guys see what I did there? So look, the revolutions cancel out, and you just have radians per second. What is 6 times 2 pi? 12 pi radians per second. Do you see how we did it, guys? Okay. You guys ready for the next one? Yeah, that was you. All right. A car has wheels with an 11-inch radius. So this is probably like a golf cart. If each wheel's rate of turn is 5 revolutions per second, how fast is the car moving in units of inches per second? Yeah, because it's a golf cart. Okay. 5 revolutions per second. Here's what you're going to do. Go 5 revolutions per second. In 1 revolution, you travel, so let me go ahead and put it right here. In 1 revolution, you travel 2 pi times your radius times 11 inches. Chop, why? Because that's what a circumference is. Circumference is 2 pi r. 1 revolution is 2 pi radians. Does that make sense? Yeah. So in 1 revolution, you travel 2 pi times 11 inches. That's my circumference. Look, revolutions cancel out, and you just get inches per second. 2 times 11 is 22. 22 times 5, what's that? 22 times 5. So 110 inches per second. Look for that answer. That answer in there? There it is right there on the next page. Yeah. Is that the last one?
Yeah.
Okay. Did all that make sense?
Yes.
All right, there it is, guys. Oh. What did it make sense? Tell me which one. Oh, I just did stoichiometry, miss. Every time if I have a wheel and it's 11 inches long, the circumference of that wheel is 2 times pi times 11 inches. So every time this wheel turns, it's covering 22 pi inches. Yes or no? But look how many turns am I making in 1 second. How many turns am I doing? 5. So I take the 22 pi. Oh, she's in Ms. Garcia's. And I multiply it by 5. And that's 110 pi inches. Do you see what we did there? Okay. All right, guys. That's it.